and welcome back to another episode of Night Sky News, your monthly space news distraction from everything going on in the real world. And this month it's all about my favourite topic, black holes. But before we get to that, let's take a look at the things that we can spot in the night sky this month, because even though we're all in lockdown, one thing that we can all do, whether it be from a window or a balcony, or for those who are lucky enough, a garden, is to look up. So on Thursday the 16th of April, which when this video goes live will be tomorrow, so early birds, you'll be able to catch this one. The moon in the early morning sky, literally right before dawn, is going to be in a nice line with three planets, Mars, Saturn, Jupiter, which will all be along the ecliptic, that sort of line which is the plane of the solar system in the sky where all the solar system objects move along. Now, if you're watching this after the 16th, don't worry, because you will have another chance to spot this in 28 days' time when the moon comes back again. By the time it's sort of May 11th to May 14th. And if it's clear all that time, you'll be able to watch the moon going from sort of nearby Jupiter on the 11th to sort of getting lower and lower when you look at the same time each night, so that by the 14th, it's again underneath them all, nearest to Mars. Then on the 19th, we've got the Lyrid meteor shower. And so all of these meteors are going to look like they're streaking across the sky from the constellation of Lyra. So what you've got to do is find that constellation and then essentially sort of put the top of your head sort of facing that constellation so that you're turning away from it, essentially. Because what you want to be able to do is look at the sky where the meteors are going to be streaking away from it, rather than the point at where they all start, because you'll miss them all otherwise. So the closest to the equator you are, the more likely you are to see meteors from the shower, because it means the constellation of Lyra will be much higher overhead. So you've essentially got like the whole sky that they'll be streaking away from. The best time to look for these is pre-dawn on the 19th, definitely after midnight at least, because you want it to be as dark as possible to be able to see the meteors, but you also want the moon to not be in the sky, because the moon is really bright and will sort of wash out a lot of the fainter meteors. And so the moon is going to be setting around dawn time, so that's going to be the time when the moon isn't quite as bright. So best time to look for them, pre-dawn on the 19th of April. Then on the 25th and 26th of April, it's my favourite sight to look out for in the night sky again, a toenail moon very close to Venus. So I call it a toenail moon. That's not its official name. It's a very thin crescent moon, but it looks like a toenail, so that's what I call it. Look to the west just after sunset and you should be able to find this. Venus is the brightest thing in the sky at the moment, so it should be pretty obvious. On the 25th, the moon will be above it, and by the 26th, the moon will be below it. So if you do manage to spot it, send me your photos, even if they're taken with just a smartphone. Smartphones are great these days at astrophotography, some of the newer ones. Send me whatever you managed to see, like a lot of people did this month. I really enjoy seeing those photos. Especially because this is really one of the last chances we're going to get to spot sort of Venus and the toenail moon, because 28 days later, when the moon actually comes back to its toenail phase, Venus will have dropped quite low in the sky and be very close to the horizon. So much so that by the end of May, actually, it will almost have completely set and we won't be able to see Venus in the evening sky anymore. Then from the 4th to the 6th of May, we have the peak of the Eta Aquarids meteor shower. So another meteor shower we can look out for. Again, after midnight is when you want to really look for these, because the sky will be much darker, but we'll also be contending with the moon again. So this is another one of those pre-dawn meteor showers if you want to get up a bit earlier and see if you can spot something. The easiest way to sort of put the radiant of the meteor shower to the back of your head in this time is going to actually be to find Mars. It should be fairly easy to find Mars because it'll be that reddish looking thing, you know, sort of in the southeast sky. So find that, turn your back on it and look at the rest of the sky. And hopefully you should be able to spot some meteors then. Then on the 6th of May, if you missed this month's supermoon that just happened, the super pink moon that everyone was raving about, where the moon wasn't actually going to look pink. The pink moon name comes from sort of Native American traditional names for the full moons in different months, and any full moon in April is always called the pink moon because it coincides with the blooming of some pink flowers. Well, on the 6th of May, there's also going to be another supermoon. This one is going to be the super flower moon. Again, something to do with flowers in Native American traditional culture. It's still a supermoon because the moon is sort of at its closest point to us in its oval-shaped orbit. It's not going to be as close as the moon was in April to us, but it's still close enough to classify as a supermoon. This is the third and final supermoon of 2020 though, so if you want to get out, take some pictures of the moon when it's nice and low on the horizon, and you have that perspective of, you know, the size of things to compare it to, so it does look bigger. It's just an illusion though. It is exactly the same size when it's low on the horizon as it is high in the sky. It's literally all to do with sort of how your eyes perceive the size of it. But last chance to get out there and get those beautiful pictures that you want. And again, send them to me if you manage to spot it. Now, moving on to space news now, because even though all of us are in lockdown, the universe and science does not stop. All right, so first up, a gorgeous picture to start with. Look at this image of the surface of the asteroid Bennu. This was taken by NASA's OSIRIS-REx spacecraft, which, if you remember, is planning to land on the surface of Bennu, get a sample of the asteroid and return it to Earth in the next couple of years, which is a very exciting mission. So this is 2,155 high-res images that have been stitched together to make this amazing mosaic. You might just think that it is a pretty image, but actually this was necessary for OSIRIS-REx's mission because it needed to map the surface of Bennu fully before it decided on a landing spot that was safe, that it was going to be free of rubble and boulders and provide a nice sort of flat, smooth landing spot for it. So the team are now analysing that image in great detail to try and figure out where to actually land. Mosaic. And one of my favorite things on space Twitter this month, you know, if you're not involved with space Twitter, like, get involved, because it's amazing. Some of the stuff on there is just incredible. And here, what the actual team at OSIRIS-REx have been doing is playing this game with the hashtag, where is that boulder on Bennu? Where they take, you know, like crop out one of the boulders from the main image and be like, where actually is this boulder on Bennu? And you've got to figure it out. So all those jokes about, you know, not being able to play Where's Wally in lockdown and social distancing because it's just too easy, you know, you've got where is that boulder on Bennu to play instead. So sticking with rocky objects in the solar system, I want to take a minute just to talk about Comet ATLAS. So this is a comet that is visible in our night sky at the minute. It's sort of on its orbit where it's coming closer to the sun. I think it just crossed Mars's orbit, so it's getting closer to us all the time. And it's visible if you have, you know, sort of a medium-sized telescope, you know, a decent sort of amateur telescope. And I hadn't actually mentioned it on this channel yet because it was forecast to get brighter as the weeks went by, sort of into April and May. And if it did that, it would eventually be visible maybe with the naked eye. And the reason comets get brighter as they get closer towards the sun is, you know, a lot of the ice in them starts to melt, that starts to outgas, that tends to reflect a lot of light, and it's a lot easier to see them. And of course, also it's closer to us, so it's easier to see it as well, rather than when it's further away. Now that was what was forecast, but comets are known to be wildly unpredictable, and this one didn't really disappoint either. Instead of getting brighter, what now people are thinking has happened is that the comet has actually broken up and disintegrated. Now, at the time of filming, that hasn't been fully confirmed yet whether that has happened. The first clue we had was images taken by some professional astronomers at a professional observatory where they had observed that instead of the tail of the comet getting longer, light would be expected if, you know, it was typically melting and outgassing as it got closer to the sun and getting brighter. Instead, the nucleus of the comet was sort of elongating. Actually, you know, the very center where the sort of rocky body and everything, all the outgassing was coming from. And when that happens, at least when we've seen that before with other comets, the comet has broken up and disintegrated. Just because, you know, because of all the ice melting and the gases being heated up by getting closer to the sun and therefore outgassing, a lot of what was holding that comet together is no longer there. So instead it breaks apart. After those professional images were taken, there have also been some amateur images taken as well that appear to show that the comet might be in pieces. But again, time of recording, that hasn't been confirmed. But I guess Editing Becky at some point will put a banner down here telling you what actually happened to this comet. Editing Becky here from the future. Yeah, that thing's toast. Then a bit of sad news that I just want to cover, and that was the passing of Margaret Burbidge on the 5th of April 2020 at 100 years of age. So an incredible age that she really did live to. She was a giant of astronomy in the 20th century and the 21st century even as well. She was the first author on a paper in 1957 with Geoffrey Burbidge, William Fowler and Fred Hoyle. And this laid out the hypothesis that all elements in the universe are made in stars, something we call stellar nucleosynthesis, i.e., nuclear fusion produces everything from helium to lithium to carbon to oxygen to nitrogen to all the way up to iron. So that oft-quoted phrase of "we're all made from stardust" comes from Margaret Burbidge's work. She then went on to study quasars for years. She ended up finding the most distant quasar known at the time. It was a redshift of 3.5, and that record held for 8 years. Despite the fact that early in her career, she was denied positions at observatories because, they were male-only observatories. Only men were allowed to use the telescopes for some reason. She ended up being the director of the Royal Greenwich Observatories in London. She also became the first female president of the AAS, the American Astronomical Society. And if that wasn't enough, during the 80s, she also helped to design the faint object spectrograph that went onto the Hubble Space Telescope, and then in the 90s used that instrument along with the huge team of people she'd amassed over the years to prove that at the center of the galaxy Messier 82, I clearly meant M87 and not M82. I just apparently can't read my own handwriting. There was a supermassive black hole at the center of it, which for me personally is, the cherry on top of the cake that was her career. She really was a trailblazer, campaigning so much against the discrimination of women in astronomy, both negative discrimination and positive discrimination. No one wants a pat on the back just because you're a woman. Like, wow, you did that and you're a woman? No. So I'm sure you'll agree that her impact on astronomy was huge, both the research side of things and the societal change that really allows me to do the job that I love to do today. So I'm very thankful for all her efforts. So even though this is a bit of sad news that I'm reporting, I hope you will join me this evening in raising a glass to Margaret Burbidge. Now, the rest of the pieces of news I have for you are all black hole related. Yes! So the first one of those was from a paper by Lynn and collaborators this month that were looking at this problem of where are all the intermediate mass black holes, these things that we call the missing link black holes between stellar mass black holes and supermassive black holes. So stellar mass black holes are those that are around about the same mass as stars. So anywhere from, say, like 5 times the mass of the sun-ish to about 100 times the mass of the sun-ish. And they're usually found in a binary system. So that's 2 objects that are orbiting around each other. So it could be 2 stars, a star and a black hole, a star and a neutron star, a white dwarf and a neutron star, whatever it is. And in fact, our sun is actually quite rare. It's not normal in the fact that it's actually alone and not in a binary system. And the reason that we find a lot of these stellar mass black holes in binary systems is because those black holes tend to get a bit greedy. They tend to pull material off the star that they're orbiting. That material then starts to spiral around that black hole, and as it does, it heats up and it starts to glow in X-rays. And so we often detect the X-rays that are from this material that's spiraling around the black hole. That's the same way we also detect supermassive black holes as well, just on a much larger scale. These are black holes that are found in the very centers of galaxies. And again, if they are active black holes, i.e. they are getting a bit greedy or hungry and taking in material from the space around them and causing this material to sort of form this spiraling disk around the black hole, then that disk will heat up because of friction, get very, very hot and start glowing in X-rays. And so we see lots of X-ray sources that are incredibly, incredibly bright compared to the binary X-ray binaries that we see where we see these stellar mass black holes. And we find those in the centers of galaxies. And these supermassive black holes are anywhere from sort of millions to billions of times the mass of the sun. And there's lots of questions still in astrophysics about how they grew that big, at least that quickly, when they're sort of found in the very early universe. But the other question that's still outstanding is, well, what about these intermediate mass black holes in the middle? The things that are sort of hundreds to hundreds of thousands of times the mass of the sun. We haven't really found anything in that regime. So that's why we call it this missing link between the small and the incredibly massive black holes. The only things we do have in that regime, we tend to term as candidate black holes. We're not entirely sure that they actually are black holes. There's no agreed upon method for finding and confirming that that's what they are. But this paper by Lin and collaborators this month was trying to confirm that a candidate intermediate mass black hole was actually an intermediate mass black hole. So back in 2018, the same authors of this paper that just got published this month published a paper saying that they'd found one of these high luminosity X-ray sources. So brighter than the black holes in the binaries that are around about the same mass as stars, but not as bright as the supermassive black holes in the center of galaxies. And they said the most likely hypothesis to explain this was that it was an intermediate mass black hole in a very dense star cluster. So you know, if you've got a lot of gas concentrated in one place, you can all of a sudden pop up and form lots and lots of stars all at the same time that are then sort of, you know, bound together by gravity into this big group or cluster. And so if there was an intermediate mass black hole in this cluster, then what would happen if a star got too close and it was sort of, again, stripped of a lot of its matter as it sort of flew past this black hole? That matter falling in on the black hole heated up and started to glow in X-rays. And from the brightness of the X-rays, you can estimate the mass of the black hole. And they did that and they found that it was maybe 50,000 times the mass of the sun. So definitely in this sort of middle regime between the stellar mass and the supermass. But what they couldn't confirm in that previous paper was whether this hypothesis of it being in a star cluster on the very edge of a galaxy that was 805 million light years away, or whether it was actually much closer to us in our own galaxy and it was actually just a neutron star glowing in X-rays. And that's why it was so bright, because it was so much closer to us. So what they've done here in this new paper that came out this month was actually try and find this star cluster at the same position of they've seen this X-ray coming from. So they actually took the Hubble Space Telescope, which is, you know, our best telescope, really great for seeing detail quite far away, which is an optical telescope. And so you wouldn't be able to see the neutron star in optical, invisible light that we can see with our eyes, but you would be able to see the star cluster, which is made of normal stars. And so what they found with the Hubble Space Telescope is they've been able to just resolve this sort of tiny patch of this star cluster on the edge of this galaxy, and also then confirm that it was at the same distance as the galaxy as well. And so now they're saying that this hypothesis of it being this intermediate mass black hole, giving off these X-rays, where these X-rays are at the exact same position as that star cluster they found in the optical data, that hypothesis is now much more likely. And so this makes it a much stronger candidate for being one of these intermediate mass black holes. Next up, Bella Dieter and collaborators have found a record-breaking blazar this month. Now, you might be asking, what in the universe is a blazar? Well, you might have heard of a quasar, and a blazar is basically a special type of quasar. So a quasar is a hungry supermassive black hole. It's a supermassive black hole that is currently taking in material at a very high rate. So I guess it's a greedy supermassive black hole, and it means that the X-ray emission that we get from this black hole in the center of this galaxy is so incredibly bright, and it means that we can see them at much higher distance than we can see, say, galaxies without an active hungry black hole, which are just starlight. And so quasars were really the furthest objects that we were able to detect very early on, like Margaret Burbidge did. And sometimes what happens to those quasars is that they will burp. Now, I've talked about these black hole burps before on my channel, and essentially what it means is that if you put too much material into that region where the black hole is all at once, for it to sort of eat it all at once, the pressure builds and builds and builds. And before even that material has crossed that point of no return by the black hole, the easiest, least energetic thing the black hole can do to ease that pressure is to throw a load of it back out, either in a big wind or in one of these really cool jet jets that come out sort of the poles of the black hole. Again, it's not coming from the black hole itself because, you know, when anything actually falls into a black hole, it can't get out again, but it's coming from this region around the black hole. And so those jets often contribute to the brightness of these quasars. They tend to be able to see that in radio emission as well. And so a quasar is essentially any of these objects where we can see it from, you know, any angle, right? We might be seeing the accretion disk face on, we might be seeing it at some angle, and again, the jets will come out at any angle to us. A blazar is essentially a quasar that we see directly down the jets. The jet is pointing straight at us, and that is a really good angle to be at because it's so much brighter, and so they're very easy to spot, especially at high distances. So this blazar is PSO J030947.49 plus 271757.31. Snappy name, I know. And it was found using the VLA Sky Survey in the radio to look for the jet, and then also the Large Binocular Telescope in Arizona to look for the visible galaxy counterpart that this quasar is, or this blazar, I should say, is living in. And also by getting the visible light, they managed to get the redshift of the blazar hosting galaxy as well, and found that it was a redshift of 6.1, which means that when that light was released and started its journey towards us, the universe was only around 900 million years old or so. So this is light from the very early universe making it to us. And that 900 million years or so is right on the edge of sort of the time we think it takes for stellar mass black holes to grow to become supermassive black holes. So it's a very interesting area of science to probe in order to be able to understand how they grow that big that quickly, and this sort of jet production that's coming towards us too. Ideally though, we need more of these blazars at that kind of distance, at that redshift, and hopefully the LSST, the Large Synoptic Survey Telescope, will give us that. It's scheduled for first light in 2020. Fingers crossed that that timescale still holds, because a lot of it has actually been delayed with everything that's going on at the minute. But hopefully when that does come online, we'll find more and more of these things, hopefully a lot easier as well with this better telescope, and then we'll be able to do some really cool sort of science and statistics on these things. So sticking on the theme of blazars for our last piece of news, on my live stream last week where I opened my 100,000 subscriber plaque from YouTube, someone asked me whether, you know, I'd heard about this news before the rest of you. And no, I heard about it as soon as it hit the headlines, just like everybody else. This was work by Kim and collaborators at the Event Horizon Telescope collaboration. So you remember the Event Horizon Telescope took that image of the black hole at the center of Messier 87. It was such a famous image. They've estimated that something like 5 billion people worldwide have actually seen this image. So I hope you all remember it from last year. I did a video on it about why it was so incredible and how they did it. And whilst most of us were expecting that the next piece of work that would come from the Event Horizon Telescope team would be an image of the center of our own Milky Way and the black hole there, which is proving a little bit difficult, I think, because it's a lot closer, so it's a much smaller black hole, and there's a lot more to sort of look through when you're looking towards the center of our galaxy as well. But I'm sure that's coming soon. But what we were treated to this month was a study on the blazar 3C279, which happened to just be in the background of that original image of M87 they took. Now they're pretty far away from each other on the sky, so it just shows you like how huge these images of the sky radio telescopes actually take compared to, say, optical images, which just look at a tiny fraction of the size of the full moon every time they take an image. Now, they couldn't resolve the actual accretion disk of this galaxy like they did for M87. There they actually showed this material sort of spiraling around the black hole and saw that black hole shadow, because this galaxy is actually 10 billion light years away compared to M87's 6 million light years away, so you can see how much further it actually is. But what they were able to resolve was really the shape and the structure of this jet that is coming from this material surrounding the black hole, because these jets are huge. They're often so much bigger than the galaxy itself. M87 has a jet and it's absolutely huge in comparison to the actual galaxy. Now, we've been able to see the shape of 3C279 jet before, but crucially what this EHT image has given us is the shape and the detail incredibly close to where that jet is actually being launched from around the black hole. Now, we don't really understand how these jets are launched very well, because we think it's something to do with magnetic fields, and the joke in astrophysics is that no one really understands magnetic fields because they're very incredibly complicated. For 3C279, for example, in this work that's come out this month, it showed that that jet very close to the black hole was twisted and bent and also rotating probably as well. So there's going to have to be lots of follow-up work done to really understand the physics that's actually going on in terms of why that jet is all bent and what's going on in terms of magnetic fields to explain that. So when those results come out, I will make sure to let you know what they find. So that's it for this month's distraction of space news. I will see you all next month, but in the meantime, stay home, stay safe, but keep looking up. She really was a trailblazer. Next up, Bella Dieter, and ow, rude.